Hello students, let's take up the topic from chemistry. We are doing acid, bases and salts, that is part 3. As we have already done that what are acids, what are bases, we have seen the classification, we have done the physical and the chemical properties also, and we have already studied about the salts and their types. So now let's take up the part. List of topics that we have covered in this video are introduction of acids, introduction of bases, classification of acid and bases, physical properties of acid and bases. These topics we have already covered in part 1. The other topics are chemical properties of acids and bases, the nature of metal and non-metal oxide, about salts. These all topics are covered in part 2. So now in this video we are going to take up the indicators and pH, the techniques of forming salts and also controlling acidity of salt. So let's start with the topic. And if you have any problem related to these topics which are previously covered, you can watch our videos of part 1 and part 2. Let's do the basic methods of preparation of salts. That how we can prepare the salts. See, we have two types of salts basically. One is soluble salts and one category is of insoluble salts. So we have different methods to prepare these salts. Like if they are soluble salts, we can prepare them by reacting the metal with acids. For example, if I take any metal, like say I take zinc, I can react with some acid and as a result I get a salt which is soluble in nature, and along with that we get the hydrogen gas. That I have already told you that if any gas is liberated and we need to test that gas, so there is a certain identification test for each gas. Like for hydrogen is that, like if by a reaction hydrogen gas is liberated and you bring a matchstick or a candle near it, it starts burning with pale blue flame and a popping sound, and the popping sound is produced. So this is how we can prepare by reacting metal with acids. Let's take one more example. Let's say I am reacting sodium with sulfuric acid. So when I react sodium with sulfuric acid, it will form sodium sulfate, and along with that we get the hydrogen gas. The second method that we can use for the preparation of soluble salts is the neutralization reaction. In neutralization reaction, we can react the acid and base, and as a result we get a neutral salt, and water. Let's take an example. Let's say we have HCl and we have a base. Both are of same strength, both are strong in nature, and as a result we get sodium chloride and water. The third method is again neutralization, but here we are reacting the insoluble base and a hot acid. Let's take an insoluble base, let's take copper oxide, and we are reacting with a hot acid. Let's take sulfuric acid. So we get a salt, that is copper sulfate, and water is produced. So these are the methods by which we can prepare the soluble salts. Now let us look at how can we prepare insoluble salts. So method of preparation of insoluble salts involve two methods. One is direct combination of elements. Direct combination means we are taking metal and we are taking the another non-metal. Let's say if I take chlorine, it will result in the formation of the salt like this. That is the direct combination take place between iron and chlorine. Similarly, we can make zinc and we can react with chlorine and it will form zinc chloride. So likewise, we can make the insoluble salt by direct combining the elements. Second is we can carry out the double decomposition reaction. Double decomposition reaction is a reaction between two compounds in which they mutually exchange their ions. Let's take an example of the general equation. So let's say if I have a compound, let's say AB, and I have another compound, let's say CD. So if I write their valencies, these are the ions like this. They will interchange their ions. That is, the A will combine with D. They will interchange their partners, you can say. And C will combine with B. So this is what is double decomposition reaction. So let's take an example. Let's say if I have sodium nitrate and I have, let's say, silver sulfate. So if the reaction takes place between them, we get, like if we write the valencies also, so we get Na2SO4 plus AgNO3. So likewise, we can carry out the different, you can say the reactions. Let's take one more example. Let's say we have barium chloride and we are reacting with AgNO3. So again, if we write their valencies, it's like that. So barium is going to react with NO3. So it is BaNO3 whole twice barium nitrate plus we get silver chloride. So likewise, the double decomposition and the direct combination of elements can produce the salts that are regarded as insoluble salts. Now, if we talk about the strength of acid and base. Strength of acid and base means how strong is the acid or how weak is the acid. Similarly, we can talk for the base, that how strong is the base or how weaker is the base. So we can classify it by taking into consideration the strength, and that strength is represented in the form of pH. So like we have acid, we have base and we have salt. So they have a certain value of pH which indicates that what exactly is the strength of acid or a base. So how we can define the pH? pH is logarithm of reciprocal of hydrogen ion concentration. This is just a definition. So how we write that pH is equal to logarithm. So we write logarithm of reciprocal of hydrogen ion means H positive, concentration, that means we have to write in brackets, within brackets. So this is how we write the expression for pH. Now, by measuring the pH, we can have the idea about the strength of the acid, that how stronger or how weaker is the acid. So this is what is the pH scale. See, this pH scale is a scale which has numerals ranging from 0 to 40. It has values like 0, 1, 2, 3, 4, 5, so on till 40. So by considering the, you can say the magnitude of the strength, we can come to know about the strength of the acid or a base. So it is regarded that if the pH falls below 7, those substances are regarded as acids. So that means this range shows the presence of acids. And if the pH is more than 7, then they are regarded as bases. This is how it actually confirms that whether the given substance is acid or a base or how strong or weak it is. And if the pH value is 7, that indicates that the substance is neutral, that is neither acidic nor basic. So we can say that when we move to extreme left from 7, then the hydrogen ion concentration goes on increasing. And if we move from 7 to right, then the hydroxide ion concentration goes on increasing. One more thing I would like to explain, like if you have a question, like you are given with the scale and you are asked that there is an acid with pH value 2 and there is another acid with pH value 4. So out of them, which is going to be the stronger acid? So you should know that 2 will be a stronger acid because lower is the pH. I'll write here, lower is the pH, stronger is the acid. Lower is the pH, stronger is the acid. Likewise, if I ask you that we have a scale and we get to see the pH value as 9 and 11. So confirm that whether they are acid or a base. So by looking at the values, you can clearly make out they are more than 7. That means they are bases. Now, if somebody asks you that out of these two, which is going to be a strong base, then the answer would be that out of 9 and 11, 11 would be a stronger base. The reason being that more is the value of pH, more is the value of pH, more stronger is the base. More stronger is the base. So this is what is the pH scale, that is ranging from 0 to 14, and 7 is the neutral point, and if you move to left from 7, it indicates that they are acids, and if you move to right from 7, it indicates that they are bases. Lower the value of pH, that means stronger is the acid, and higher is the value of pH indicates that it is more basic in nature. Now, observation made on the basis of pH value, that how we are going to see that how stronger or how weaker is the acid or a base. So if the pH range between 0 to 2, that means it is a strong acid. So 0 to 2, that means it is a strong acid. And if it is 2 to 4, then it is moderately acidic. And if it is more than 4, then it is a weak acid. And if it is 7, I told you before also that it is neutral in nature. 7 to 10, that means it is a weak base. 10 to 12, it means it is moderately basic. And more than 12, it is strongly basic in nature. Now, what is the effect of dilution on pH in case of acids and bases? Let's say if we have an acid, and we add water to it. Let's say this given acid initially possessed pH that is 2. Now I am adding water to it. So what happens to its pH value, whether it increases or decreases? So whenever you add water to an acid, it becomes less acidic. So that means its pH will increase. Its pH will be more than 2 in this case. And if you have a base, if I have a base with value 9 and now I am pouring water to it, so it will become less basic now. So its pH value will decrease because its strength will decrease. So in case of acids, on dilution, the pH increases, and in case of bases, on dilution, pH decreases. Now, what is the importance of pH? See, pH has a great importance in different sectors, like it has a biological importance. See, our body works within 7 to 7.8 pH. Like our body can function properly if the pH is 7 to 7.8. Similarly, the pH of acid rain is below 5.6. You know that acid rain, that means water with dissolved acidic oxides in it. So otherwise we know that the pH of water is 7, that it is neutral. But when the acidic oxide gets dissolved, it forms acid rain, due to which its pH is below 5.6. And you know that this acid rain affects the monuments, affects the soil, it affects the aquatic life as well. Second is the role of pH in agriculture. See, plants need specific range of pH for survival and in order to grow as crops. So in agriculture also it plays an important role, because there are certain crops which can grow in acidic soil. There are certain crops which grow in a soil which has pH that is more than 7. So it has an agriculture importance also. In dairies also it plays a role, like the pH value of milk is adjusted to be about 6.6. But if the pH falls below 6.6, it turns sour. So that means whether the milk is in a proper condition or it has become rancid can be known by taking its pH value into consideration. Even it plays an important role in tooth decay. As you know that we all encounter a problem, that is the tooth decay. You know that the tooth decay starts when pH of mouth falls below 5.5. At this much pH, what happens? The acid reacts with calcium phosphate of our tooth enamel and cause it to corrode. And this mainly occurs when we eat some sugary substances. It leads to the production of an acid which starts corroding the enamel. So that means the tooth decay is also just because of the sugary substance, because they are producing acid, and those acids are lowering the pH of the mouth, and that is the reason the tooth decay, that is the cavities, occur. Now we are going to take up a topic, that is acidic nature of soil. We all know that soil is very important to us. Soil is very important to us because the soil is the one that sustains plants. And if plants are not there, even our food chain will get disturbed. Even we know that they are autotrophs, right? So how we'll get the food? So that means soil is very important. Similarly, the soil has nutrients in it. The soil possesses nutrients in it that makes it fertile. That is the reason that it can actually help the plants to grow. But sometimes what happens, there can be too much of aluminium in the soil and less amount of calcium and magnesium. So if the aluminium amount suddenly increase or calcium or magnesium amount suddenly decrease in the soil, due to this, the soil becomes somehow more acidic. Now, some plants cannot grow well in the acidic soil. So, to make the soil back to a fertile condition, we need to remove this acidity. So, how we remove that? It can be controlled by adding pulverized, that is in a powder form, limestone to the soil. You know that limestone is CaCO3. So, if you add this pulverized calcium carbonate to soil, it acts as a neutralizer and it retains the original chemical nature of the soil and excess acidity is controlled. Now let's do another topic, that is indicators. What are indicators? We have already studied in part 1 that there is one litmus, that is an indicator, and the acid and base can affect its color. So indicators are the substances that can bring about the change in themselves, that is the change in its own nature. Can be a nature change, can be a smell change, can be any kind of change. When this change occurs, when some acid or a base is added to them. So I think you got it. Indicators are the certain substances that bring about change in their odor or in their color, or you can say in any other property when acid or base are added to them. Like we have phenolphthalein as an indicator. There are certain indicators which actually change, which actually bring about the change in their smell, right? So they are olfactory indicators. And the indicators such as vanilla extract also. Some can actually show a change in color, some can show a change in smell likewise. So the indicators are classified into two categories. They can be natural indicators, they can be artificial indicators. Natural indicators are those which are obtained from plants and animals, that is, they are naturally occurring. For example, the popular natural indicator is litmus. Litmus is extracted from lichens. Litmus is extracted from lichens, which is actually, you can say, an association of fungi and algae. So, originally, the litmus is purple in color. But when in lab we make use of it, they are used in the two forms, that is red color litmus and blue color litmus. So, there is the effect of acid and base on the colors of this litmus. That is, when it reacts with acid, it turns blue litmus red. And the effect of base is that it turns red litmus blue. Right, but initially its color is purple. Please keep in mind, because you may get a question like this: what is the original color of litmus and from where it is obtained? So these two things are very important. Otherwise, as far as effect is concerned, acid turns blue litmus red and base turns red litmus blue. Now we talk about artificial indicators. Artificial indicators are the man-made indicators. They are phenolphthalein, methyl orange, and lots more. But these are the common ones, so we are going to take up this two in this video. So phenolphthalein has a certain, you can say phenolphthalein shows a certain change when acid or base reacts with it. And if you talk about its original color, it is colorless. So when it is treated with acid, it remains colorless. But when it is treated with base, it turns pink in color. As you can see that this is phenolphthalein. So when it is treated with base, it becomes pink, and when it is treated with acid, it remains colorless only. Even at 7 pH, it is colorless. The another is methyl orange. The initial color of methyl orange is orange, as the name specifies. So what is the effect of acid? Acid changes the color of methyl orange from orange to red, and the basis changes the color of methyl orange from orange to yellow. We have olfactory indicators as well. That is, they can bring about the change in their smell when any substance is added to them. So, the olfactory indicators are onion extract, vanilla extract, and lots more. But we'll be taking these two examples in this video because they are included in your syllabus. So, vanilla extract is one of the olfactory indicator, and one is the onion extract because they have characterized smell. Now, what is the effect of acid on vanilla extract, and what is the effect of base on vanilla extract? So, when acid is added to vanilla extract, there is no change in smell. That is, the smell remains the same. But when base is added to vanilla extract, you can say the vanilla essence characterized smell vanishes off. It vanishes off. And if we talk about the effect of acid on onion extract and the base on onion extract, then it is again the same, that when acid is added, there is no change in the, you can say the smell of onion extract. But if base is added, the smell of the onion vanishes. That is, the characterized smell vanishes off. Now let's do few question and answers in order to see that what you have learned through this video. Write the value of pH at which our body works. So our body works well at pH 7 to 7.8. So we can say that it is a range that lies between this pH value. Next question is, how we come to know that milk has turned sour? So we can come to know when its pH falls below its normal pH, that is 6.6. Next question is, at what pH tooth decay starts and why? The pH below 5.5 results in the tooth decay because when we eat some sugary substance, the acid is secreted that lowers the pH of mouth, and this acid reacts with tooth enamel, that is Ca3PO4, and corrodes it. Explain the pH scale. Now, we know that pH scale is a scale whose having a values ranging from 0 to 40. It has the values like this, that is ranging from 0 to 40. So this is 8, 9, 10, 11, 12, and this is 13. Right. So now this 7 is regarded as a neutral point. The 7 is regarded as a neutral point. So the pH values that are less than 7, that means these ones belongs to acids, and the pH values more than 7 belongs to bases, right? So these are acids and these are bases, and 7 is a neutral substance. So we can say that on this side the hydrogen ion concentration is increasing in this manner, that is when we are moving towards the left of 7. And on this side, the concentration of hydroxide ion goes on increasing as we move towards the right of 7. Now, we can write this as lesser the pH than 7, stronger is the acid, and more is the pH than 7, stronger is the base. So this is what is the pH scale. But if into any substance we add water, like if we add water to an acid, its pH value increases. Its pH value increases and its strength decreases. And if we add water to a base, its pH value decreases and again its strength also decreases. Now we need to complete few reactions. One is sodium hydroxide with nitric acid. So we have sodium hydroxide, we know NaOH. We have nitric acid, that is HNO3. So let's complete this. So we can see that these are two compounds. So there is the double decomposition reaction that will occur. So just write the valencies like this. So after interchanging the ions, it will lead to the formation of sodium nitrate and water. Another reaction is the reaction of sulfuric acid with calcium carbonate. So sulfuric acid is H2SO4, calcium carbonate is CaCO3. Let's write the valencies: H positive, SO4 2 negative, Ca2 positive, CO3 2 negative. So when they will interchange their ions, so we'll get to see that it leads to the formation of calcium sulfate and water, and carbon dioxide is released. Third reaction is where we are going to react zinc carbonate with hydrochloric acid. For zinc carbonate, we have ZnCO3 and HCl as hydrochloric acid. Now, let's write the valencies again. So, the valencies are Zn2 positive, CO3 2 negative, H positive, Cl negative. So, they will interchange their valencies. They will form ZnCl2, then they will form H2O and CO2. Another reaction is iron with sulfur. That is, it is the direct combination. And we know that direct combination leads to the formation of insoluble salts. So we have Fe plus S, they will form FeS, that is iron sulfide. Now we have sodium carbonate with calcium chloride. Sodium carbonate is Na2CO3, calcium chloride is CaCl2. Let's write their valencies. It is Na positive, CO3 2 negative, Ca2 positive and Cl negative. So the reaction that will occur will be NaCl and CaCO3. That is, we get sodium chloride and calcium carbonate. Next reaction is silver nitrate with potassium chloride. Silver nitrate is in AgNO3, potassium chloride is KCl. Let's write their valencies. So these are the valencies. So when they will interchange their ions, it will form AgCl and we'll get KNO3, that is silver chloride and potassium nitrate. Another reaction is the lead nitrate with potassium iodide. So lead nitrate is PbNO3 whole twice, potassium iodide is Ki. Let's write their valencies. 2 positive, NO3 is negative, potassium is positive and iodine is negative. So when they will interchange their ions, it will form lead iodide, which is yellow in color. It is a precipitate and we get potassium nitrate. So this is how you're going to attempt the reactions if you get a question like this. And most of the reactions we did in this section were double decomposition reaction, and these reactions lead to the formation of salts. Now let us do another question, that what are double salts and what are complex salts. See, double salts are those salts that contain more than one cation or more than one anion. As you all know, that cations are the atoms with positive charge and anions are the atoms with negative charge. So if the salt possess more than one type of cation or more than one anion, then they are called as double salts. Like the example we have is potassium sodium tartrate, that is TARTRATE. This is a double salt. Likewise, we have another example, that is ammonium. We have ammonium, right? Iron 2 sulfate. This is an example of another double salt. Likewise, we have many double salts. When these salts are dissolved in water, they get completely ionized to form the ions from which they are formed. Now let us see what are complex salts. Complex salts are those salts that contain one or more complex ions, and these ions have metal centers and different molecules are attached to it. Right, that is, they contain one central metal atom and the different molecules are attached. These are mostly, you can say, the coordinate complexes. For example, we have potassium ferrocyanide. We have potassium ferrocyanide. The formula for it is K4FeCN whole 6. So in this is a central metal atom. This is also a metal atom. So more than one, you can say, the ions are there, and these are different molecules attached. Similarly, we have an example, that is potassium silver. In this, the silver is called as argento. Right? There are specific rules which we follow while writing the coordination name. So it is potassium argento cyanide. So cyanide is Cn whole twice. So this is again another example. Likewise, we have more examples like tetraamino cupric sulfate, which is written as CuNH3 whole 4 SO4. So this is the tetraamino cupric sulfate. So while you are writing this copper and ammonia has to be there in the square bracket, and sulfate is in counter ion, so it is written outside. So you can enclose everything into a one bracket. Let me write this again in order to make you more clear. See, this is like this, copper, and we have ammonia, and they are 4 in number. This is a, you can say, a coordinated sphere, coordination sphere, and sulfate is the counter ion. So here the name is tetraamino cupric sulfate. So these are complex salts, and when these salts are dissolved in water, they do not get completely ionized. This part, that is coordination sphere, is ionized together, and this is ionized separately. So that means they both will get separated like this, but this sphere, that is ammonia and copper, will remain along with each other. Another question we have is, give example of acidic salt, complex salt, basic salt, neutral salt, and double salt. So acidic salt is like we have NH4Cl. So ammonium chloride is an example of acidic salt. And if we talk about the complex salt, so let's take example. We have already discussed few examples. So let's take this example, potassium ferrocyanide. So this is K4, Fe is the central metal atom, Cn whole 6. So it's like this, potassium ferrocyanide. Example of basic salt. So basic salt here is, CH3COONA, that is sodium acetate. And if we talk about neutral salt, we can take an example of our table salt, that is NaCl. And next is double salt. The example for the double salt is potassium sodium tartrate. Potassium sodium tartrate is an example for double salt. Thank you for watching this video. For more learning experience, you can visit www.wasarax.com. So with this, the chapter acid, bases and salts is finished.